Welcome to Sleepy Science Facts. It's a pleasure to have you here tonight. As the gentle whispers of the evening wrap around you, I invite you to find a comfortable position, allowing your body to melt into the softness of your space. If you enjoy this soothing journey, feel free to like and subscribe, but only if it brings you joy. Beneath the tranquil surface of our Earth lies a fascinating world, hidden away from our daily sight. Imagine a solid inner core composed mostly of iron and nickel, resting deep within the planet. This core is incredibly hot, reaching temperatures that mirror the fiery surface of our sun. Yet despite this intense heat, the pressure in this depth is so immense that the core remains solid. Surrounding this solid inner core is a liquid outer core, flowing slowly, its movement a slow dance over vast stretches of time. This liquid layer plays a crucial role in creating the Earth's magnetic field. As it shifts and flows, it generates the magnetic forces that protect our planet. For millions of years, this magnetic field has quietly persisted, enveloping the Earth in an unseen embrace. The layers below us continue their slow, rhythmic motions, shaping our world over geological epochs, their secrets woven deep into the fabric of the planet. There is so much more to discover in this enigmatic realm, inviting us to explore quietly, one soft fact at a time. The coastlines of our planet are in a constant state of gentle change. Waves gracefully lap against the shore, their rhythm steady and eternal. This action, coupled with the pull of tides, reshapes the land, smoothing rough edges and giving rise to new forms. As time moves on, the erosion of cliffs and land gradually alters the landscape. Bits of sand and rock are carried away, their journey slow yet inevitable. In response, new beaches can emerge, formed from the very materials that were once part of another shore. Continually, the Earth finds a balance, shifting and adapting in its own quiet manner. Islands may rise slowly from the depths or vanish beneath the waves, their stories intertwined with the ceaseless pull of the ocean. The dance of water against land has created a tapestry of coastlines unique to each region, a delicate interplay of erosion and deposition, enduring through the ages. This gentle transformation invites reflection, reminding us of the slow, beautiful changes that nature orchestrates, inviting us to listen to its whispers as time flows quietly onward. Beneath our feet, the Earth is structured into distinct layers, each one forming a concentric shell around the center. The innermost layer, consisting mainly of iron and nickel, is the deepest part of this arrangement. Over billions of years, these heavier elements have gradually moved toward the center, settling into a dense core. Surrounding this core, the mantle consists of hot, semi-solid rock that flows slowly, its movements contributing to the warmth beneath our surface. Above the mantle lies the crust, a thin layer where we stand, walk, and live. This crust, composed of lighter materials, floats atop the denser layers below. Even through the vast expanse of time, this arrangement has remained stable, a testament to the processes that shaped our planet since its formation, approximately 4.5 billion years ago. The balance of layers keeps the Earth intact, maintaining a quiet harmony that has persisted throughout epochs. This enduring structure presents a serene reminder of the deep, hidden world beneath us, waiting patiently as time unfolds. Deep beneath the surface, soil quietly develops through an intricate process that unfolds over thousands of years. It begins with the gradual weathering of rocks, where natural elements like wind, water, and temperature changes gently break down solid stone into finer particles. As these rocks crumble, they create a rich foundation where life can flourish. Alongside this, decaying plant material adds organic matter to the mix. Fallen leaves, broken branches, and other remnants quietly decompose, nourishing the earth. This slow combination of mineral particles and organic matter creates a living layer teeming with microorganisms, all contributing to a balanced ecosystem. Over time, these layers transform, becoming more structured and enriched. Nutrients gather, and the soil becomes an essential habitat for countless organisms. It transforms barren land into landscapes filled with greenery, helping seeds take root and grow into vibrant plants. This unhurried, continuous process of soil formation ensures that the earth remains fertile and supportive. In its own time, soil patiently nurtures life, reflecting the gentle cycles of nature as it continues to evolve. Movements of the Earth's tectonic plates, a whispering dance known as continental drift, unfold at a remarkably slow pace. This gradual shifting allows continents to drift apart or move closer over millions of years, reshaping the world in small, subtle increments. As these vast land masses glide over the molten layer beneath, they give rise to natural features like mountains, valleys, and ocean basins, each formed with patience and precision. This gentle movement fosters the evolution of ecosystems, permitting flora and fauna to adapt to new and changing environments. Species find their niches over time, adjusting to varying climates, altitudes, and geographical barriers. With each slow shift, interconnected habitats emerge, fostering rich biodiversity. Changes unfold in a manner that allows organisms to thrive, fostering a balanced relationship within their surroundings. The slow rhythm of continental drift paints a picture of a living planet continuously evolving, nurturing life in all its forms. This serene process continues, quietly reminding us of the deep connections that bind our planet together. Coral reefs, often referred to as the rainforests of the sea, quietly expand over time through the diligent work of tiny coral animals called polyps. These delicate creatures build their homes by secreting calcium carbonate, layer upon layer, creating intricate structures. Each polyp, small and unassuming, contributes to the greater whole, forming massive reefs that can stretch for miles beneath the ocean's surface. As generations of polyps grow and flourish, the reefs take shape, becoming homes not only for countless other marine organisms, but also fostering a rich tapestry of life. Fish, mollusks, and crustaceans find sanctuary within the nooks and crannies of the coral. Algae, which often live symbiotically with the polyps, add color and vibrancy to these underwater landscapes, creating an ecosystem vibrant with activity. Over many years, these reefs reflect a careful balance, where each element plays a role in sustaining the life around it. The steady, unhurried growth of coral reefs illustrates a remarkable process, allowing them to develop into complex habitats, supporting a network of life that thrives in their embrace. With each slow accumulation of coral, the underwater world continues to evolve, fostering an environment rich in diversity. Antarctica, often recognized as the largest desert on Earth, presents a world defined by its remarkable aridity and profound cold. The expansive ice sheets and crystalline landscapes stretch endlessly, characterized by an environment that can plummet to temperatures as low as -100 degrees Fahrenheit or -73 degrees Celsius during the long winter months. This chilling atmosphere fosters conditions where moisture is scarce, making it one of the driest places on the planet. Despite its icy facade, Antarctica functions as a vast, silent desert, where winds sweep across the surface, sometimes reaching speeds that create a hauntingly beautiful, yet harsh soundscape. The sunlight, when it does shine, casts a clear, brilliant light on the snow and ice, revealing textures both soft and stark, illuminating the contours of this frozen realm. Little life exists under such extreme conditions, yet the land still harbors a unique array of organisms adapted to endure its cold embrace. The stark white expanse can feel timeless, marked by slow, steady changes shaped by the elements. The ice flows and glaciers, although seemingly still, are constantly shifting, inching forward as the layers compact and reshape over millennia. This cycle of weathering and accumulation tells a story of resilience in a world where survival is a profound challenge. The tranquility envelops the landscape, inviting a sense of wonder about the delicate balance of life and the environment in this remarkable desert. Rivers, in their gentle persistence, weave through the earth, carving valleys over long periods. As water flows, it carries with it tiny particles of soil and rock, slowly eroding the banks and bedrock beneath. With each year, the path of the river inches deeper, carving out the landscape in subtle yet profound ways. This slow process of erosion shapes the terrain, giving rise to intricate valleys and bends that tell a story of time. Along the banks, the rushing water nurtures a unique ecosystem, harmonizing the elements of land, air, and water. The flow is steady, creating a rhythm in the landscape that can be both serene and dynamic. Over thousands of years, what began as a small stream can transform into a wide riverbed with steep cliffs and gentle slopes that reflect the journey of the water. Each twist and turn reveals the influence of the river on the earth around it as the landscape adapts and evolves. The valleys, shaped by this delicate balance of erosion and deposition, become a soft embrace of movement and stillness. In this way, the rivers continue their journey, a quiet force sculpting the land for generations to come, inviting contemplation of the relentless beauty of nature's design. The Earth's magnetic field, a quiet but essential feature, varies in strength across different regions, typically ranging from 25 to 65 microteslas at the surface. This field acts as a protective shield, gently deflecting harmful solar radiation that bathes the planet in delicate bursts. It forms a barrier, allowing life to thrive by creating safe conditions within the atmosphere. Despite its stability over centuries, the magnetic field does undergo gradual changes. These subtle shifts can be noted over long stretches of time, sometimes even leading to magnetic reversals, where the magnetic north and south poles swap places. Such events unfold over geological timescales, altering the planet's magnetic landscape in ways that scientists study and marvel at. The stability of the magnetic field, coupled with its slow transformations, contributes to the dynamic environment of Earth. Within this ever-present embrace, life continues, adapting to the gentle rhythms of the planet's invisible forces. As these magnetic interactions play out silently, they weave a tapestry of protection and change, a reminder of the complex and tranquil systems that exist all around us, guiding the world through the vastness of space. Certain types of starfish possess a remarkable ability to regenerate lost arms, a process that occurs slowly and gracefully within their bodies. When an arm is lost, whether due to a predator or other environmental factors, the starfish can begin the intricate journey of regrowing it. This regeneration may involve the careful reorganization of cells and tissues, a seamless transformation that unfolds quietly over time. What is particularly fascinating is that in some cases, a single lost arm can give rise to an entirely new starfish. This occurs when the severed arm contains a portion of the central disc, which houses vital structures. From there, the arm begins to develop into a new body, a a testament to the resilience and adaptability of these marine creatures. Such regenerative abilities not only help starfish survive, but also enable them to thrive in diverse aquatic environments. The peaceful ocean currents may carry them through many challenges, yet they remain steadfast, using their unique capabilities to flourish. In the depths of the ocean, these wondrous beings continue their life cycles, reminding us of the beauty of renewal and the hidden strength within living systems. The quiet rhythm of life beneath the waves unfolds, carrying on the legacy of survival and transformation. The water cycle flows softly through our world, a continuous and gentle movement that sustains life in myriad forms. Water shifts between solid, liquid, and gas states, seamlessly transitioning with delicate grace. Ice, in its crystalline structure, often rests peacefully on mountaintops or floats gracefully in oceans. As the sun's warmth envelops these frozen layers, they gradually melt, transforming into liquid water that nourishes the land and fills the lakes and rivers. Some of this liquid water ultimately rises into the air, changing into vapor as it warms. This vapor, light and invisible, drifts upward, creating clouds that drift across the skies. When these clouds gather enough moisture, they release it back to the earth in the form of rain or snow, replenishing the water sources that many ecosystems depend upon. The cycle then patiently begins anew, each phase flowing into the next without interruption. This constant movement of water maintains a delicate balance, ensuring that fresh water becomes available for plants, animals, and habitats around the globe. As this cycle continues, it rhythmically nurtures the earth, reminding us of the quiet power of nature's processes. In the stillness of night, echoes of this ongoing dance resonate softly, reflecting the tranquil harmony of water's eternal journey. Ocean salinity, a gentle balance of dissolved salts, has drifted within a stable range for extensive stretches of time. This consistency is crucial for the health of marine ecosystems. Salt in seawater comes from the Earth's crust and is carried into the oceans through rivers and streams. As this water flows, it picks up minerals, which gradually mix into the vast bodies of salt water. The concentration of salt in the oceans can fluctuate, but it remains remarkably steady on a large scale. This controlled salinity supports a myriad of life forms, from the smallest plankton to the largest whales. It regulates buoyancy and influences how organisms interact within their habitats. Beyond nourishing life, the salinity of the oceans plays a subtle role in regulating the global climate. The interaction of salt water with ocean currents creates patterns that distribute warmth across the planet, influencing weather and climate systems. This intricate balance continues, a silent thread woven into the fabric of the natural world, sustaining life and maintaining a dynamic equilibrium that endures through the ages. As we drift deeper into rest, the serene stability of ocean salinity ebbs and flows gently, inviting a peaceful connection to the rhythms of our planet. Erosion quietly transforms the landscape, a gentle process that unfolds over vast stretches of time. It begins when wind and water, in their persistent movement, meet rocks and soil. The soft caress of raindrops can gradually loosen particles from their resting place. Likewise, flowing rivers carry these particles downstream, shaping the earth as they meander along their paths. Wind whispers across arid landscapes, picking up tiny grains of sand and stone, moving them toward other surfaces, where they wear away the edges and corners of larger formations. This delicate dance results in the slow formation of valleys, where land dips down into a whispering embrace, cradled by the material that has been worn away over millennia. Cliffs rise high above, their steep faces etched by time, revealing the layers of history that reside within the rock. Each moment of erosion, though small on its own, contributes to a vast tapestry of change. Continually sculpted by the Earth's elements, these landforms emerge and evolve, creating a diverse and intricate environment. The process unfolds steadily, a natural cadence that invites a sense of peace as one contemplates the enduring power of nature's forces. Each gentle shift hints at a deeper story, echoing softly in the quiet embrace of the landscape. The average surface temperature of Earth, resting softly at around 15 degrees Celsius, is a reflection of a delicate balance. This temperature has found a steady state over countless years, shaped by the sun's warm light and the planet's own gentle release of heat. Solar radiation bathes the Earth, its energy warming the surface and sustaining a variety of life. In response, the planet continually radiates this energy back into space. This interplay, a quiet exchange between the warmth of the sun and the cool embrace of the cosmos, plays a crucial role in ensuring that temperatures remain relatively stable. Also influencing this balance are the oceans and the atmosphere, which act like a soothing blanket, helping to moderate extremes and distribute heat across the globe. Winds circulate gently, carrying warmth from one region to another, ensuring that no place gets too hot or too cold for too long. As this process continues slowly and unceasingly, it creates an environment where life can flourish and adapt, whispering stories of survival and magnificence across the ages. This temperature balance serves as a reminder of the harmonious rhythms of our planet, fostering a calm foundation for the wonders that lie within its embrace. The Wilson cycle unfolds over immense periods, a slow dance of geological activity that shapes the very surface of the Earth. This cycle involves the gradual opening and closing of ocean basins, the product of the constant movement of tectonic plates beneath our feet. As these plates shift, they create rifts where oceans begin to form, allowing water to fill the spaces where land once stood. This process takes eons as the Earth slowly morphs, teasing apart continents and laying the foundation for new oceanic expanses. Over many millions of years, these basins grow and transform, inviting diverse marine life to thrive. Amid this gentle ebb and flow, supercontinents emerge, where vast land masses come together, unified. Yet just as this union is formed, the cycle continues. Eventually, the same forces that brought the continents together will pull them apart again, returning to the initial state of rifting and formation. A seamless journey unfolds over geological time, with oceans rising and falling, continents drifting apart and reconvening, creating a serene backdrop to the slow, rhythmic heartbeat of our planet's structure. This ongoing cycle speaks to the enduring and unhurried pace of Earth itself, allowing a sense of continuity and peace in the grand tapestry of existence. Mountains stand tall, majestic features of our planet, yet their presence is not fixed for eternity. Over time, they are shaped by the forces of weathering and erosion, gentle processes that work steadily and silently. Wind sweeps across their surfaces, carrying tiny particles that chip away at rock. Rain falls, seeping into cracks and crevices, slowly dissolving minerals and causing fragments to loosen. Ice plays its part too, creeping into these fissures and expanding when it freezes, further breaking the rocks apart. As these forces continue their unhurried task, mountains gradually lose their height, transforming their once proud peaks into gentle slopes and rounded forms. Each cycle of change contributes to a landscape that continually evolves, revealing softer contours and changing appearances in response to nature's persistent touch. Through this slow process, the rugged giants of the earth soften, becoming a testament to the quiet power of time. The interplay of elements reshapes them, leaving behind valleys and hills that tell stories of patience and resilience. There is a tranquil beauty in watching these transformations unfold, a reminder that even the mightiest heights are not beyond the ceaseless embrace of nature's gentle forces. Beneath the surface of the earth, a gentle warmth emanates from deep within, a phenomenon known as the geothermal gradient. This gradient signifies the way temperature increases as one moves deeper into the Earth's crust. The depth at which this rise begins can vary from place to place, influenced by the materials and conditions found in different regions. This gradual increase in temperature plays a vital role in shaping the subsurface environment. As heat flows upward, it influences the presence of water, minerals, and other elements that support small ecosystems nestled in these hidden layers. Life in these shadows, from tiny microbes to larger organisms, thrives despite the absence of sunlight, relying on the warmth that percolates through rock and sediment. While each layer of the earth offers unique physical properties, the steady flow of heat ensures that these ecosystems can remain stable and vibrant over long periods. The delicate balance of temperature allows various processes to unfold, nurturing diverse forms of life in a world unseen from above. Such systems exist quietly, interconnected beneath our feet, illustrating the profound yet subtle dynamics of nature's hidden heat. The exploration of these subsurface realms reveals new perspectives on the richness of life, gently reminding us of the complex interactions that occur far below the surface. The Earth's crust is a tapestry of different rocks, each type telling a part of the planet's story. Igneous rocks form from solidified magma, their origins connected to the fiery depths of the Earth. Sedimentary rocks, on the other hand, emerge from the accumulation of particles, like grains of sand and small fragments of other rocks, layering gently over eons. Metamorphic rocks represent a transformation, evolving from existing rocks under heat and pressure, revealing how dynamic this crust can be. As time flows onward, the forces of nature work tirelessly to reshape these rocks. Erosion gently wears away the surfaces, while rivers and winds transport materials across landscapes, gradually breaking down larger formations into smaller particles. This sediment can eventually settle, forming new layers, contributing to the cycle of life within the crust. Subduction, a powerful geological process, allows older materials to be pushed down into the mantle, where they may melt down into magma once again. This continuous recycling creates a harmonious connection between the different rock types, ensuring that they are in a constant state of change. With each phase of this slow yet persistent dance, the crust changes shape and character, creating and erasing features over vast stretches of time. It is a quiet reminder of the Earth's ongoing evolution, silently adapting beneath our feet. As these layers deepen and alter, they remain a part of the intricate balance of the planet's structure, grounded in an ever-moving cycle. Solar cycles reveal the intricate and rhythmic nature of the sun's magnetic field, transforming gradually over approximately 11 years. During these cycles, the sun experiences fluctuations in activity, including the emergence and disappearance of sunspots, which are dark patches that appear on its surface. These spots are connected to intense magnetic fields, and when they are abundant, the sun is in a phase of heightened activity. This increased magnetic activity influences the amount of solar radiation emitted towards Earth, leading to variations in climate and weather patterns. During periods of heightened solar activity, the intensity of the sun's output can increase slightly, warming the planet just a fraction more. Conversely, during quieter phases, the decrease in solar output can bring subtle changes to the Earth's climate system. The dance between the sun's magnetic activity and its radiation levels is a gentle reminder of the sun's role in shaping our environment. As these cycles unfold, they contribute to the wide-ranging patterns of climate variability that can be observed over years and decades. The sun, in its rhythmic cycles, continues to engage with our planet in a manner that is both steady and profound, weaving a tapestry of energy that glows down upon us through time's flow, quietly guiding the intricate systems of nature. Ball lightning is a captivating natural phenomenon that sometimes graces the landscape during thunderstorms. These glowing spheres float gently through the air, glowing with a soft light that can range from yellow to red. Their appearance is fleeting and unpredictable, often lasting only for a few seconds. This elusive feature can make it difficult for scientists to capture and study, leaving many questions about its formation and properties. The exact mechanisms behind ball lightning remain a mystery, as accounts of its appearance vary widely among observers. Sometimes they hover close to the ground, while at other times they seem to drift higher into the atmosphere. Scientists speculate that they may be linked to electrical discharges occurring in the atmosphere during storms, yet the specifics of their creation are still unclear. Research continues, with scientists employing various methods to analyze this enigmatic phenomenon. Each observation adds a piece to the puzzle. Understanding ball lightning not only unveils its secrets, but also enhances our grasp of atmospheric physics. As nature unfolds its wonders, phenomena like ball lightning remind us of the complexity and beauty of the world around us, inviting quiet contemplation and curiosity. Deep within the earth lies the mantle, a vast layer that extends far beneath our feet. Here, the temperature gradually rises as one moves deeper into this immense geological structure. At its deepest reaches, temperatures can soar above 4,000 degrees Celsius, creating an environment where solid rock behaves differently than what one might expect. This intense heat causes the materials in the mantle to slowly flow and move, though much of it remains in a solid state due to immense pressures. The combination of heat and pressure creates a remarkable setting where convection currents develop. These currents play a crucial role in the behavior of tectonic plates above, influencing their movement and interactions over time. The mantle's steady temperature increase is not uniform. It varies based on the location and composition of the rocks. Some regions may experience heat more intensely, producing different dynamics in how the mantle materials circulate. This ongoing movement leads to a complex and ever-evolving system deep within the Earth. As these materials shift and flow, they remind us of the hidden processes that shape our planet. The heat of the mantle continues to drive geological changes, reflecting the intricate dance of elements that provides insight into the Earth's interior. Each moment, this slow yet constant activity shapes the world above, echoing the continual transformation of the Earth itself. In the vastness of the Earth, deserts can gradually shift and expand, a process that unfolds over many years. This transformation is often influenced by a delicate balance of vegetation and climate. When plants are removed, either through natural processes or other influences, the soil becomes more vulnerable. Without the protective cover of roots and foliage, the ground is more likely to erode, and the moisture that once nourished the surrounding areas can evaporate more quickly. As the climate changes, temperatures may rise, and rainfall can become scarce. These factors combine to create an environment where plant life struggles to survive. Over time, the landscape begins to alter, transitioning from lush areas to arid expanses. This slow but persistent shift can have profound effects on local ecosystems, as the species that once thrived in these environments adapt or disappear. The delicate interplay between climate and vegetation shapes not only the physical appearance of deserts, but also the complex web of life that exists within them. Each shift in the landscape tells a story of resilience and adaptation, reminding us that change is a constant companion in nature. The ongoing process continues to evolve, quietly affecting the rhythms of life in these arid regions. Each moment, the earth transforms in ways almost imperceptible to the eye, yet profound in their impact. Deep within the earth, the core is a source of immense heat, a phenomenon that plays a crucial role in shaping our planet. This heat arises primarily from the decay of radioactive isotopes, a slow and steady process that occurs over millions of years. As these isotopes break down, they release energy, contributing warmth to the surrounding layers. This heat is not merely a static presence, it drives geological processes that are essential to the dynamics of the Earth. It fuels the movement of tectonic plates, guiding them as they glide atop the molten rock of the mantle. These movements can create mountains, valleys, and over long expanses of time, even reshape continents. The heat from the core also influences volcanic activity, leading to the bubbling of magma beneath the surface. As the molten rock rises, it can sometimes erupt, sending lava and ash into the atmosphere. These events are part of a continuous cycle, where energy from deep within fuels changes at the surface, gradually transforming the landscape. Over the ages, this quiet yet powerful process unfolds, revealing the incredible complexity of the Earth's inner workings. Each moment of decay, each flicker of energy, contributes to a grand dance of creation and transformation, a reminder of the deep and vibrant life that exists beneath our feet. In this way, the core remains a constant source of warmth, subtly guiding the evolution of the world above. And at the heart of the Earth, temperatures soar to remarkable heights, reaching approximately 5,400 degrees Celsius, or about 9,800 degrees Fahrenheit. This intense heat exists within the core, where pressure builds to extraordinary levels. Here, the immense weight of the Earth's layers above compresses the core materials, creating a unique environment that is both hot and dense. This extreme heat causes the materials in the core to behave differently than they would at the surface. Iron and nickel, the primary elements of the outer core, exist in a molten state, swirling and flowing under the influence of heat and pressure. Within the inner core, the immense pressure solidifies these elements, forming a solid sphere, yet surrounded by the fluid outer core. As heat radiates from the center, it gradually moves outward through the mantle and crust, affecting the temperature of the Earth's surface and influencing its geological activity. This steady transfer of heat is essential for driving convection currents in the mantle, which in turn sustain the movement of tectonic plates. Each process intertwines, showing a continuous flow of energy from the depths of the Earth to its surface, fostering a dynamic and ever-evolving planet. The core remains a foundation of our Earth's structure, a constant source of heat and energy, enveloped in a calm and silent embrace of pressure and warmth, quietly shaping the world around it. Deep within the Earth, the temperature can ascend to approximately 5,700 degrees Celsius, a staggering number that parallels the surface of our Sun. This immense heat exists in a realm where the inner core is subjected to extraordinary pressures, reaching levels so intense that they prevent substances from turning into liquid, despite the scorching temperatures. The inner core remains solid, a dense sphere composed mainly of iron and nickel. The force of gravity compresses these elements into a stable form, creating a unique balance between heat and pressure. With temperatures soaring, the core is a dynamic state of matter, yet it withstands these conditions in a remarkable display of resilience. Around this inner core lies the outer core, where the heat causes iron and nickel to flow in a liquid state. This fluid motion is crucial to the Earth's geophysical processes. The contrast between the solid inner core and the fluid outer core underlines the complexity of our planet's internal structure. Such an interplay of elements and temperature continues to shape our world, resonating with a quiet energy beneath the surface, still, yet profoundly impactful. Each layer, each particle, holds secrets waiting to be gently explored. Soil formation unfolds over an extended period, often taking thousands of years to develop fully. This gradual process begins with the weathering of rocks, where elements such as wind, water, and temperature variations gently break down solid materials. Tiny particles are released as rocks crumble and fracture, creating a foundation for what will eventually become soil. Simultaneously, organic matter, such as decaying leaves, plant roots, and microorganisms, begins to accumulate on the ground. This organic material, rich in nutrients, interacts with the weathered rock particles. Over time, these components blend and evolve, leading to the distinct layers of soil known as horizons. Each horizon carries unique characteristics based on its composition and the processes that have shaped it. The delicate balance of mineral particles, air, water, and organic substances creates a living system that supports various forms of life. This slow transformation continues quietly, unseen beneath our feet, layering history within its depths. Each moment adds to the rich tapestry of soil, a testament to nature's patience and complexity, enriching the earth in a subtle, persistent manner. Certain plants possess a remarkable ability to influence the timing of their growth, allowing their seeds to remain dormant within the soil for years. This fascinating mechanism enables seeds to pause in a state of stillness, waiting patiently for conditions to become ideal for germination. As seasons change and environments fluctuate, these seeds lie silently, sheltered beneath layers of earth. During this dormancy, the seeds may endure fluctuations in temperature and moisture, sensing the environment around them without actively growing. Their hard outer coatings often protect them from harsh elements, while internal processes can remain stable until the moment is right. When favorable conditions, such as warmth and adequate moisture, finally arrive, these seeds awaken. They begin to draw in water and nutrients, initiating a transformative process that leads to sprouting. This strategy allows the plants to time their emergence with the arrival of the best opportunity for growth and survival. In this serene waiting period, life is held in delicate balance, poised and ready to flourish anew when the moment is perfect. Atmospheric pressure, a gentle force that blankets the earth, holds a delicate balance at sea level, averaging around 101.3 kilopascals. This measure, while seemingly stable, can subtly shift in response to the changing patterns of weather. As high and low pressure systems move through the atmosphere, they create variations that gently influence the pressure we experience. These fluctuations can be quite small, but may lead to noticeable changes in the environment. For example, a low pressure system may bring clouds and precipitation, while a high pressure system often leads to clear skies and calm conditions. Despite these temporary shifts, the average pressure tends to drift back towards that mean of 101.3 kilopascals over time, a reassuring return to equilibrium. The atmosphere wraps around the planet like a soft, protective layer, regulating itself through these natural rhythms. The constant interplay of pressure systems and their ephemeral nature illustrates a serene cycle, softly responding yet returning to a stable state, much like the ebb and flow of a tide. This tranquil balance cradles all layers of the atmosphere, allowing life to thrive beneath its watchful presence. Biodiversity within ecosystems forms a rich tapestry of life, woven through intricate relationships among countless species. Each organism contributes to a delicate balance, supporting one another in a web of interactions that can adapt over time. These relationships are often complex, creating a network that fosters resilience in the face of environmental changes. In these ecosystems, every species plays a role, whether as a producer, consumer, or decomposer. This diversity allows for various responses to disturbances, such as changes in climate or habitat. A rich array of plants and animals means that if one species faces challenges, others may thrive or fill in the gaps. This interdependence helps maintain stability, ensuring the ecosystem can continue to function effectively. Over time, as conditions shift, biodiversity acts like a safeguard, allowing environments to withstand and recover from stresses. This dynamic interplay among living organisms fosters a sense of harmony within nature, an everlasting dance of life that adapts while holding together the fabric of an ecosystem. Its intricate connections whisper softly of balance and continuity, encouraging a serene understanding of the world around us. Glaciers, those immense rivers of ice, move gracefully yet powerfully, shaping the land around them as they glide down mountains and across valleys. This slow, persistent motion begins at the highest altitudes, where compacted snow transforms into dense ice over time. As gravity pulls, the glaciers inch forward, their weight and momentum carving out the earth beneath. The process alters the terrain, creating deep valleys and rolling hills that tell a story of countless years of gentle pressure. When temperatures rise and glaciers begin to melt, they retreat, leaving in their wake clear blue lakes and winding rivers. These fresh bodies of water, formed by the melting ice, fill the hollows and carve new paths through the landscape. As the water flows, it continues the shaping process, further sculpting the earth over time. Each ripple and wave adds a new layer to the ongoing transformation of the environment. The cycle of melting and flow creates a serene yet dynamic habitat, nourishing an array of ecosystems that thrive in the cold, crisp water. In this quiet dance of ice and water, the earth transforms slowly, revealing beautiful landscapes shaped by the hand of nature. Through the steady movement of glaciers and the gentle release of their waters, the land continues to evolve, inviting curiosity and wonder about its ever-changing form. Deep within the Earth's crust, immense stresses build up over long periods. These forces arise from the movements of tectonic plates, which shift and interact with one another slowly, almost imperceptibly, over years and centuries. As the stress increases, it becomes like a tense string, stretched tight and waiting for release. It is in those hidden depths, far beneath the surface, that the ground holds its breath, preparing for the moment when it can no longer contain the energy within. When the energy finally finds its escape, it manifests as an earthquake. In an instant, the ground shakes, a powerful release of accumulated forces, reshaping the landscape. Cracks may form, hills may tumble, and valleys may shift, all within moments, transforming the environment, much like a sculptor working with clay. This sudden change, though swift in its occurrence, results from a long history of gradual changes beneath the surface. Ecosystems, too, can be altered in profound ways by these events. Rivers may change their course, habitats can be disrupted, and new landscapes emerge. In the aftermath, nature begins to find its balance again, reclaiming what has changed and healing the scars left behind. The earth continues its gentle cycle of stress and release, reminding us of the dynamic nature of our planet, where quiet buildup precedes sudden transformation, all part of an ongoing rhythm. Throughout Earth's history, it has experienced long, rhythmic cycles known as ice ages. These vast spans involve periods where glaciers expand over continents, carving landscapes with their slow-moving ice, and stretches where warmer temperatures prevail, allowing regions once covered in ice to flourish again. Each ice age unfolds over approximately 100,000 years, a gentle ebb and flow between cold and warmth. During glacial periods, ice sheets creep across the land, reshaping valleys and creating new geographical features. These thick masses of ice hold incredible weight, compressing the ground beneath them, changing the very contours of Earth. In contrast, as temperatures rise in the interglacial phases, large expanses of ice melt, releasing vast amounts of cold water into the oceans. This process alters sea levels and influences the global climate, fostering ecosystems that thrive in warmer conditions. These cycles are not simply drastic changes, but a ballet of transformations, where each phase contributes to the rich tapestry of Earth's landscape. Over millennia, this interplay of ice and warmth has influenced everything from the formation of rivers to the development of different geological features, reflecting the planet's long-term adaptability and resilience. As the Earth breathes in its cycles, life continues to adapt, creating an ongoing narrative woven into the fabric of time. Carbon travels through various systems on Earth in a delicate balance known as the carbon cycle. It exists in the atmosphere as carbon dioxide, where plants absorb it during photosynthesis, using sunlight to create energy while releasing oxygen as a byproduct. The lush forests and green landscapes become a vital part of this cycle, acting as a natural filter for carbon. As plants and animals die, their remains are broken down by decomposers, returning carbon back to the soil. This organic matter enriches the earth, supporting new life in a continuous process. Some carbon from the soil eventually journeys into the oceans, where it dissolves in seawater. Here, marine plants like phytoplankton also utilize carbon dioxide, fostering underwater ecosystems. Over vast periods, geological processes lock carbon away in rocks and fossil fuels. This dynamic interplay of decay, growth, and mineral formation ensures that carbon remains in a continuous loop, contributing to the health of the environment. Each part of this cycle influences the next, creating a stable and nurturing habitat for all forms of life. The rhythm of the carbon cycle echoes through the ages, fostering a sense of interconnectedness within nature's systems, quietly supporting the delicate balance of life on Earth. Beneath the surface of the Earth, the mantle is in constant motion, driven by convection currents. These currents flow like a slow, gentle tide as warmer material rises toward the surface, while cooler, denser material sinks. This gradual movement creates a dynamic environment where tectonic plates shift and slide over one another. As different plates interact, stress builds along their edges. Eventually, this pressure is released, resulting in an earthquake. The vibrations ripple through the ground, marking the sudden release of energy that is accumulated over time. Yet, these geological movements are not always abrupt. They can be very gradual, corresponding to the slow dance of plates reshaping the Earth. Over millions of years, the collision of these plates can lead to the uplifting of land, forming mountains that stretch toward the sky. The landscape transforms ever so quietly, eroding and weathering over time, giving rise to valleys and plains as well. These changes are both significant and subtle, creating a tapestry of Earth's surface that reflects the slow, unyielding forces beneath. Each shift and rise contributes to a story written slowly across the ages, integrating the deep history of our planet. The continuous motion of the Earth below feels like a gentle reminder of the ever-evolving nature of the world we inhabit. Rocks exist in a continuous cycle, a gentle movement that carries them through various forms over immense spans of time. At the beginning of this cycle, igneous rocks are formed from cooled molten magma. As they gradually rise to the surface, many begin their journey of breakdown. Erosion plays a crucial role here, as wind, water, and ice wear away at these rocks, breaking them down into small particles, grains, and sediments. Once these fragments are settled, they undergo a process called sedimentation. Over time, layers of sediment accumulate, compacting and solidifying into sedimentary rocks. This formation is a quiet, patient process that occurs beneath the surface, often accompanied by the slow pressure of materials building atop. Eventually, when sedimentary rocks are buried deeper within the earth, the heat and pressure can transform them into metamorphic rocks through a process known as metamorphism. This transformation allows the rocks to change, becoming denser and altering their mineral composition. Each stage of the cycle contributes to the gradual reshaping of the Earth's crust. Through time, rocks can return to their original molten state, beginning the cycle anew. This rhythmic journey of creation, destruction, and transformation occurs silently, weaving a story of the Earth's geology beneath our feet. The rock cycle continues, gently reminding us of the ever-changing nature of the world around us. Seawater, a vast blue expanse, holds a unique property known as electrical conductivity, measured at approximately 4 Siemens per meter. This conductivity arises from the dissolved salts that inhabit the water, particularly sodium and chloride ions. When these salts dissolve, they break into free ions, creating an environment where electric currents can flow more easily, which is a crucial feature of seawater. While this conductivity remains relatively stable, it is subject to gentle fluctuations influenced by various factors. Changes in temperature can affect how well these ions move, as warmer water allows them to speed up, enhancing conductivity. Similarly, the salinity, or salt concentration, plays a significant role. Higher salinity results in more ions in the water, further increasing the conductivity. Environmental changes, such as rainfall or evaporation, can alter salinity levels as well. Rain can dilute seawater, while evaporation can concentrate the salts, both impacting conductivity in subtle yet profound ways. Over time, the interplay of these variables brings about a dynamic system reflecting the continual shifts in the ocean's conditions. As the seas ebb and flow, the conductivity remains an important trait, an indicator of the changing environment beneath the surface, and gently reminding us of the interconnected nature of water and its components. The ocean, with its intricate balance of ions and currents, quietly continues its dance, ever ready to share its secrets. Beneath the familiar surface of the Earth, deep within its layers, lies the outer core. This remarkable region is composed of liquid iron and nickel, swirling together in a complex dance. The outer core exists at intense temperatures and pressures, causing the metals to remain in a molten state. The movement of this liquid metal is not random. It flows in slow currents, influenced by the rotation of the planet and the convection currents caused by heat escaping from the inner core. These currents play a crucial role in generating Earth's magnetic field. As the liquid iron and nickel move, they create electrical currents, which in turn produce magnetic fields. This process, known as the geodynamo, maintains a protective shield around the Earth, extending far into space. The magnetic field serves to deflect harmful solar winds and cosmic radiation. Over time, the behavior of the outer core has a rhythm, with patterns that change but remain consistent over long periods. This dynamic system interacts with the layers above it, influencing geological phenomena and helping define the very nature of our planet. The outer core continues to quietly flow beneath our feet, a hidden source of energy and protection, constantly shaping the environment around us. Softly, this liquid layer persists, embodying a powerful yet tranquil force, ready to reveal more of its secrets as the Earth's story unfolds. Deep within the Earth, the core exerts intense pressure and heat, reaching extreme temperatures that melt rock into magma. This molten rock is less dense than the solid material surrounding it, allowing it to rise slowly toward the surface. Over time, as magma pushes its way upward, it can create a variety of geological features. When it breaks through the surface, we see the emergence of volcanoes, which release hot lava and gases, reshaping the landscape with each eruption. The process of volcanic activity is not just about forming mountains and craters. It also plays a quiet but essential role in changing local ecosystems. As new landforms are created from the solidified lava, they provide fresh terrain for plants and animals, gradually fostering new habitats. This ongoing cycle of eruption, cooling, and growth allows life to adapt and thrive, even in challenging environments. The heat and pressure from the Earth's core continually influence this cycle, fueling a dynamic system that drives the Earth's ever-evolving crust. Gradually, deep within the planet, this process unfolds and reshapes the world, a constant reminder of nature's subtle yet powerful presence. Something profound continues beneath our feet, patiently paving the way for the land and life above to flourish. The Earth's orbit around the Sun is a delicate dance, maintaining a path that is mostly consistent over long periods. This stable orbit, paired with the Earth's axial tilt, creates the rhythm of the seasons. As the planet spins on its axis, different regions receive varying amounts of sunlight throughout the year. This gentle tilt, about 23.5 degrees, allows for a gradual change in temperature and daylight, crafting the familiar cycle of spring, summer, autumn, and winter. Each season unfolds at its own pace, bringing changes in weather patterns and temperature. These predictable cycles influence how plants grow, how animals behave, and how ecosystems change over time. Seasons affect the availability of resources and the various interactions within habitats. With this steady orbit and tilt, the Earth ensures that life has a chance to adapt and flourish. The tranquility of these movements offers a sense of continuity, linking generations as the seasons softly transition one into the next. This enduring stability creates a soothing backdrop for the rich tapestry of life, inviting a sense of calm in the knowledge that these patterns will persist, patiently shaping the world. Glaciers, immense bodies of ice, glide slowly over the land, a process that is almost imperceptible to the observer. They shift and flow, driven by the weight of their own mass and gravitational forces. As they move, Glaciers carve out distinct shapes in the landscape, sculpting valleys and creating depressions that may later fill with water and form lakes. Each small shift in the glacier's position contributes to a gradual transformation of the terrain around it. This gentle but persistent movement occurs over thousands of years, leaving behind unique landforms when the glaciers finally retreat. The valleys may take on a U-shape, wide and smooth, while the remnants of the glacier's path can create ridges known as moraines. As glaciers melt, they release fresh water, accumulating in the basins they have helped to shape. These lakes can be serene and tranquil, often framed by the very mountains and valleys forged through the glacier's monumental journey. The process is slow and rhythmic, a testament to the power of nature's forces working in harmony over vast timescales. The landscapes shaped by this ancient movement whisper of the past, where ice and land have danced together to create the beautiful scenery we see today. This quiet transformation continues, an endless cycle of growth and reshaping, reminding us of the gentle power of Earth's processes. Heat flows steadily from the depths of Earth's interior, a soft and continuous energy that emerges at an average rate of about 0.08 watts per square meter. This gentle warmth rises slowly to the surface, contributing to the delicate balance of Earth's thermal dynamics. Over long periods, this heat flow remains remarkably stable, creating a consistent background warmth that influences many geological processes. Yet this tranquility can be punctuated by events such as volcanic eruptions or tectonic movements. These activities can disrupt the otherwise steady heat flow, causing fluctuations that can be observed in the surrounding land. For instance, when magma pushes through the crust, it brings a surge of heat that influences the local geology, altering temperature and pressure in its vicinity. This interplay between stability and change reflects the dynamic nature of Earth's interior, where heat is constantly generated through radioactive decay and the gradual crystallization of materials. As geological activity stirs beneath, the surface remains a quiet witness to these ongoing processes. The heat that emerges nurtures the very fabric of the Earth, promoting a cycle of change that shapes landscapes over eons. This slow and persistent energy flow, both stable and occasionally disrupted, underpins much of the Earth's remarkable geological features, perpetually adapting and transforming the world just beneath our feet. Gravity, a constant presence throughout Earth, exerts a gentle force that holds everything in place. This invisible pull affects all materials, the rocks, minerals, and fluids deep within the Earth's crust. It is this gravitational force that shapes the internal structure of the planet, contributing to the immense pressure experienced below the surface, which plays a crucial role in the formation of magma. As materials compile under the weight of gravity, they become compacted, creating an environment where heat and pressure work together. Under these conditions, certain elements begin to melt, forming magma, a molten mixture that arises from the Earth's interior. The rules of gravity guide this process, ensuring that the production of magma is steady, establishing a rhythm within the Earth's fabric. When conditions reach a tipping point, this magma can rise towards the surface. Gravity helps it navigate through the cracks and fissures of the crust, patiently making its way upward. Such movements can eventually culminate in volcanic activity, where magma escapes, transforming into lava and reshaping the landscape above. The balance between gravity and the materials it acts upon creates a silent yet dynamic interplay. It holds all elements together, allowing for a continuous cycle of formation and transformation within the Earth. Beneath the surface, this constant force crafts a world of quiet movements. For forever shaping the planet while remaining unseen. Coral reefs form in a gentle, gradual manner, unfolding their intricate structures over centuries. At their core, these vibrant ecosystems are built by tiny organisms known as coral polyps. Each polyp is a delicate creature anchoring itself to the reef and depositing calcium carbonate, a substance that serves as its protective skeleton. This process of deposition happens slowly, layer by layer, contributing to the expansive architecture of the reef. Through countless generations, polyps collaborate in their growth. They extend their soft, waving tentacles, capturing small particles of food from the water around them. This nourishment supports their growth, allowing them to thrive in harmony with sunlight and ocean currents. The warm, shallow waters become a nurturing environment, facilitating this intricate dance of life. Over time, these tiny builders construct vast structures, transforming their surroundings into vibrant undersea landscapes. The calcium carbonate accumulates, forming platforms where diverse marine life can flourish. Fish, crustaceans, and other organisms are drawn to the shelter and resources that the reef provides. As currents wash gently over their surfaces, the reef continues to evolve, shaped by the slow, persistent actions of its tiny architects and the teasing tides above. This process of formation is a testament to resilience and longevity, encapsulating the quiet rhythm of life beneath the waves. As layers build upon one another, the reef remains a tranquil presence in the water, continuously growing and adapting within its environment. The underwater world of coral reefs thrives in a timeless cycle of creation, patiently awaiting the next moment of transformation as life ebbs and flows around it. The Earth's magnetic field is a subtle yet powerful force woven into the very fabric of our planet. This magnetic field originates deep within the Earth, in the fluid dynamics of the molten iron that swirls in the outer core. As this molten iron moves, it creates an electric current. This current, in turn, generates the magnetic field that extends far out into space. This gentle shield plays a crucial role in safeguarding our atmosphere. Solar winds, which are streams of charged particles emitted by the sun, would otherwise strip away the delicate layers of gases that envelop the Earth. With each gust of these solar winds, the magnetic field acts as a barrier, deflecting these particles and preventing them from wreaking havoc on our atmosphere. Over countless years, this protective mechanism has helped maintain the conditions essential for life. It allows for a stable environment where the atmosphere can balance, nurturing seasons and cycles over the ages. The magnetic field, while often unnoticed, serves as a constant reminder of the interactive and dynamic processes occurring within our planet's depths. As time passes and the Earth continues its quiet rotation in the cosmos, this magnetic field remains steadfast. It cradles the atmosphere gently, an unyielding guardian against the forces beyond, ensuring that life can thrive and evolve across millennia. All the while, the unseen movements of molten iron persist, continuing the cycle of protection that has endured through the ages. Deep within the Earth's layers, a slow, transformative process unfolds over millions of years, driven by the weight of accumulated sediments and the warmth of the planet's interior. As layers of organic matter settle in quiet beds along ancient seabeds, they become buried beneath more sediments. Over time, the immense pressure from these layers compresses the organic material, shifting it and igniting a chain of chemical reactions. This pressure, combined with heat, transforms the remains of tiny plants and creatures into substances rich with energy, known as fossil fuels. The process is gradual, unfolding in geological time, as nature orchestrates its silent symphony beneath the surface. Each step, compaction, heat, and chemical alteration, works harmoniously to create the fuel that lies in wait within the Earth's crust. These fossil fuels, formed from once living organisms, encapsulate energy from the distant past. They rest within intricate geological formations, often tucked away in layers that tell stories of a time long gone. When conditions are right, this stored energy can find its way back into the environment. Through natural processes, it may eventually be released, echoing the life that once thrived on the surface. This cyclical journey of energy reminds us of the deep connections within the Earth, cycling from life to sediment, and then back to energy once more. In the quiet depths of the planet, this process continues steadily, a gentle reminder of the slow workings of nature. The layers of time and energy are ever present, weaving a narrative of transformation that persists far beyond the moments we perceive above ground. Beneath the surface of the Earth lies the mantle, a thick layer of semi-solid rock that extends for hundreds of kilometers. Within this layer, immense pressure builds over time. This pressure arises from the weight of the materials above and from the heat of the Earth's core. As the mantle flows slowly, like a gentle river, its movement influences the tectonic plates that make up the surface of the planet. These plates drift at a remarkably slow pace, inching along their paths over thousands and millions of years. Sometimes, as these plates move, they collide, pull apart, or slide past one another. Each small shift within the mantle can create significant changes in the Earth above, reshaping continents and forming mountains, valleys, and ocean basins. This continuous dance of the plates is part of a larger cycle that defines our planet's geology. Occasionally, the stress that builds at tectonic boundaries becomes too great, resulting in sudden releases of energy. This can lead to earthquakes which ripple through the crust, altering the landscape in an instant. Yet, even these quakes are simply a part of the ongoing slow evolution of the Earth's surface. The process remains constant, a cycle that endlessly reshapes the world around us, carving and molding over eons. The quiet, steady movements within the mantle contribute to the rich tapestry of geological change, reminding us of the Earth's dynamic nature. This slow and subtle grandeur continues as time flows forward, nurturing a planet defined by transformation and resilience. Deep within the Earth, the outer core is a layer of molten iron, constantly in motion. This flowing metal creates electric currents, which in turn generate the Earth's magnetic field. This magnetic field surrounds our planet like a protective blanket, extending far into space. It plays a vital role in shielding the Earth from solar radiation, diverting charged particles that would otherwise interact with our atmosphere. The movements of molten iron are influenced by convection currents, where hot material rises and cooler material sinks, creating a dynamic flow. This activity is ongoing, continuously changing the magnetic field in subtle yet significant ways. The magnetic field itself is not constant. It shifts and fluctuates over time, a reflection of the ever-changing currents in the outer core. For thousands of years, this magnetic shield has acted as a guide for various life forms and natural phenomena. Many animals rely on the magnetic field for orientation, while its impact reaches far beyond the surface. Navigational instruments, like compasses, respond to the field, providing a reliable reference point for direction. The gentle ebb and flow of the outer core creates a magnetic environment that is not just a layer of protection, but an intricate part of the Earth's structure. This continuous cycle connects the innermost parts of our planet with the cosmos outside, further weaving the tapestry of life on Earth. Deserts possess a remarkable ability to change over time, growing quietly and slowly as climate conditions shift around them. This expansion occurs subtly, often imperceptibly at first, as temperatures rise and rainfall diminishes. Areas once alive with vegetation begin to dry out, gradually succumbing to the encroaching sands and rocky landscapes that characterize arid environments. The plants that once thrived in these regions cannot sustain themselves with limited water and shifting temperatures. As they begin to vanish, the land transforms, with less vegetation to hold the soil together. Wind erodes the ground, carrying away particles and further facilitating the advance of the desert. The air becomes drier, and the landscape shifts from green to golden hues as life finds it increasingly difficult to anchor itself in such a harsh climate. This gradual process unfolds over years and decades, marking one of Earth's natural rhythms. The boundaries of deserts are not fixed. They expand and retract in response to the long-term patterns of climate. In this way, ecosystems can be lost, replaced by the vast stretches of a desert silence, where only the rustling grains of sand tell the tale of transition. Solar radiation plays a vital role in shaping the Earth's surface through a gentle and persistent interaction with the atmosphere. As sunlight reaches the surface, it warms the rocks and minerals found in mountains, plains, and valleys. Over time, this heat, along with changes in temperature, causes these materials to expand and contract, initiating a slow process known as weathering. This process works gently, allowing rocks to gradually break down into smaller particles. Rainfall, carried along by the air, also contributes to this transformation. As water seeps into cracks and crevices, it can freeze and thaw, further weakening the rock structures. Tiny particles created through weathering start to accumulate, paving the way for new forms of life. As these fragments combine, they create soil, a fundamental component for ecosystems. This slow transformation of rocks into fertile ground supports plant life, which further alters the landscape over long periods. Through this continuous cycle, solar radiation influences not just the weathering of materials, but plays a quiet role in the very development of our planet's landscapes. The interplay of sunlight, air, and water remains a soft, ongoing process, shaping Earth in harmonious ways, patiently unfolding as the ages pass. Mount Everest rises majestically into the atmosphere, reaching an impressive height of approximately 8,848 meters, or 29,029 feet above sea level. This towering peak, part of the Himalayas, is composed mainly of sedimentary rock that formed from ancient ocean floors. Over millions of years, tectonic forces pushed these layers skyward, creating the magnificent mountain we see today. The journey to this height is marked by a gradual transition through varying climates and ecosystems. From the warm, lush foothills that cradle the mountain, the air grows increasingly thin and cool as one ascends. Each elevation introduces a different world of conditions, shaping the mountain's surface. Snow and ice play a significant role in the appearance and structure of Everest. These elements accumulate over time, creating glaciers that flow slowly down the mountainside, further sculpting the landscape. Wind and temperature fluctuations continuously carve out features, subtly changing the peak's profile. With every passing season, the layers of snow shift and mold, contributing to an ongoing cycle of development, while nature quietly shapes and reshapes this colossal entity. The mountain stands, still and enduring, a testament to the slow passage of time and the ever-changing processes at work in the Earth's crust. A serene tranquility envelops this grand formation, inviting a deeper connection to the rhythms of the planet and the natural world. The ocean is a vast expanse of water, filled with a complex mixture of chemicals that continuously shift and blend. Over time, the composition of seawater changes slowly, influenced by a variety of natural processes, and wind patterns move across the surface, creating currents that mix warm and cold water, distributing nutrients and elements necessary for life. Rainfall introduces fresh water, while rivers carry minerals from the land into the sea, enriching its chemistry in a gentle, ongoing cycle. Additionally, the activities of marine organisms contribute to this ever-changing landscape. Phytoplankton, for example, draw in carbon dioxide and release oxygen, playing an essential role in the ocean's health. As they thrive or decline, they subtly influence the balance of gases dissolved in the water. Human impact also adds to these shifts. Pollution can introduce new compounds into oceanic systems, while climate change alters temperature and salinity patterns. Together, these factors slowly weave a tapestry of change that can affect marine ecosystems profoundly, influencing everything from coral reefs to fish populations. This delicate balance supports the regulation of climate, as the ocean stores and releases heat and carbon. In this vast fluid environment, the interplay of elements functions quietly and steadily, reminding us of the interconnectedness of all life beneath the surface. As the ocean continues its rhythmic dance of change, it remains a steadfast presence on our planet. Some species of jellyfish exhibit a remarkable capability known as transdifferentiation. Among them, Turritopsis dohrnii stands out as a fascinating example. Once these jellyfish mature, they possess the unique ability to revert to an earlier stage of their life cycle. This transformation is not merely a simple return. It involves complex biological processes that allow the jellyfish to change its cells, essentially transforming back into a juvenile form. As water conditions around them shift, the jellyfish can respond by altering its cells, a graceful adaptation that opens a path to a new beginning. In this state, the organism retreats from its adult phase, allowing it to escape the stressors of maturity. This extraordinary ability seems to allow certain jellyfish to dodge the finality of aging, creating the potential for what feels like an indefinite life cycle. The elegance of this process reflects nature's intricate dance of life. Within the depths of the ocean, these jellyfish float, embodying a cyclical existence that is both simple and profound. The hush of the water envelops them, where they drift like whispers of resilience, continuing their journey in a world that is ever-changing. Each transition they undergo serves as a gentle reminder of life's fluidity, where beginnings and endings intertwine seamlessly. Wind is a subtle yet powerful force that shapes the Earth's landscapes in quiet ways. As sunlight warms different areas of the planet's surface unevenly, variations in temperature create pockets of air that move in delicate currents. These gentle breezes, growing into stronger winds, begin to interact with the world around them. As they flow over rocks and sediments, they carry small particles away, gradually sculpting the land. Over time, relentless winds continue to wear down rugged formations. They chip away at rocky cliffs and carry the dust and sand to new places. Valleys emerge from once towering heights, becoming softer as the landscape shifts. Plains can form where once there were obstacles, spreading wide under the vast sky. Each gust contributes to this slow transformation, an ongoing process that unfolds silently. The land continuously evolves as the winds shape its contours. These changes may take centuries, but they reveal a persistent dance between air and earth, creating a serene symphony of gradual alteration. Each moment, the wind whispers its stories to the earth, leaving an imprint that tells of a time unhurried, allowing the landscape to unfold in soft, gentle waves. Deep within the earth lies a molten iron core, swirling and moving in patterns that give rise to a sturdy magnetic field. This magnetic shield wraps around the planet, creating a protective barrier that extends far into space. Its presence is gentle yet profound, quietly safeguarding the Earth from the harshness of solar radiation and cosmic rays. As charged particles from the Sun travel through the cosmos, they encounter this magnetic field, which deflects many of them away. Instead of bombarding the surface, these energetic particles are redirected, creating a serene balance between the solar winds and our planet. In this way, the magnetic field does not merely exist, it continually interacts with the dynamic forces of the universe. Over time, the Earth's magnetic field has ebbed and flowed, sometimes strengthening and at other times becoming weaker. This long-term behavior mirrors the calm rhythms of nature itself. It reveals a world where unseen currents shape existence, allowing life to thrive in relative safety. The heartbeat of the Earth whispers softly, reminding us of the delicate interplay between our planet and the cosmos, ever present and ever watching, ready to continue its silent guardianship. The geologic timescale stretches across immense spans of time, dividing Earth's history into vast eons, eras, and periods. Within this intricate framework, each division marks significant chapters in the ongoing story of our planet. Over millions of years, life has flourished and adapted, moving through cycles of evolution that reflect the changing conditions of the Earth itself. Amidst these long stretches, there have been moments of profound change. Mass extinctions punctuate the timeline, each one reshaping the landscape of life. These events often alter entire ecosystems, creating space for new forms of life to emerge and evolve. The rhythm of existence is both steady and tumultuous, allowing for resilience in the face of change. Throughout the ages, species come and go, leaving imprints in the geological record. Fossils and rock layers tell tales of ancient environments and the creatures that once roamed them. Gentle shifts in climate, sea levels, and landscapes weave a fabric of continuity, each thread connecting past to present. In this vast tapestry of time, the Earth remains ever evolving, quietly guiding the cycles of life, open to the unfolding mysteries that still lie ahead. The specific heat capacity of Earth's surface materials, including soil and rock, typically ranges between 800 and 1,200 joules per kilogram for each degree Celsius. This characteristic allows the Earth to absorb heat during the day, gradually warming the ground and influencing temperatures above. As the sun sets and the air cools, these materials slowly release stored heat, creating a gentle warmth that can linger into the night. This process plays a subtle yet important role in shaping local climates. Warmth emanating from the ground can moderate temperature fluctuations, allowing ecosystems to thrive in a more stable environment. Different types of soil and rock have varying capacities for heat retention, contributing to diverse microclimates across regions. Light sandy soils, for instance, warm quickly in sunlight, while denser clay retains heat more gradually. The slow release of heat also means that changes in temperature do not occur abruptly, fostering a sense of balance in nature's cycles. Over time, this steady rhythm influences the growth patterns of plants and the behaviors of animals, reinforcing the interconnectedness of the Earth's systems. Each material, shaped by countless years of geological processes, harmonizes with the natural world, creating a soothing backdrop to the ever-evolving landscape. The climate of various regions can change slowly, often shaped by natural processes that work over long periods. Volcanic activity, for instance, can influence local and global climates. When a volcano erupts, it releases gases and ash into the atmosphere. These materials can affect sunlight reaching the Earth's surface, temporarily cooling temperatures or altering weather patterns. This effect can last for years, creating variations in conditions that ripple through ecosystems. Similarly, ocean currents play a crucial role in climate regulation. As water moves across the globe, it carries heat and moisture with it, impacting the temperatures of coastal areas and, in turn, regional weather patterns. Currents can shift due to changes in wind patterns, temperature, or salinity, leading to gradual modifications in climate over centuries. These subtle adjustments can lead to variations in precipitation, influencing how much rain or snow falls in a particular area. Through these slow processes, ecosystems adapt over time, responding to the gentle changes in their environments. The interplay of volcanic activity and ocean currents creates a dynamic system where every element connects to the next, contributing to the Earth's ever-evolving climate. As these shifts unfold, they shape the landscape, supporting the flow of life in a rhythm that continues through the ages, inviting a calm sense of wonder. The mantle lies beneath the Earth's crust, composed primarily of silicate minerals rich in iron and magnesium. These minerals give the mantle its unique characteristics. Under the immense heat and pressure found in this deep layer, these silicate minerals can transform their structure. This transformation occurs slowly, often taking millions of years, as the minerals undergo changes in their crystalline forms. As heat seeps into the mantle from the core, it creates conditions that can induce flow in this layer, allowing it to behave somewhat like a viscous liquid over geological timescales. The way the minerals interact during this process can lead to changes in their physical properties, influencing how they respond to stress and temperature. Heat increases the energy of the mineral structures, enabling them to shift and adapt in response to their environment. This slow, continuous movement within the mantle plays a crucial role in the dynamics of the Earth, contributing to various geological activities over vast periods. The interplay of minerals, heat, and pressure creates a foundation for the processes that shape the surface of the planet, forming a soothing rhythm of transformation that unfolds deep within. Each subtle alteration contributes quietly to the ongoing cycle of creation, a steady hum of geological change that continues in a tranquil, unhurried manner, fostering an ever-deepening sense of connection to the world beneath our feet. Forests, with their diverse ecosystems, evolve gradually over time. Natural selection guides these changes, allowing certain tree species to flourish in response to the specific climate and soil conditions of a region. As seasons come and go, trees compete subtly for sunlight, water, and nutrients. This gentle competition shapes the forest's character, favoring those species best suited to the environment. Over centuries, shifts in temperature or moisture can lead to the slow dominance of particular species. Some trees thrive in cooler conditions, while others may prefer warmer or wetter climates. The soil, rich with organic matter and minerals, plays a significant role in nurturing specific types of trees, creating pockets of diverse habitats within the same forest. As this interplay between climate, soil, and tree species unfolds, entire landscapes can transform, creating an intricate tapestry of life. New generations of trees rise, shaped by their predecessors and the environment around them. The slow dance of growth, decay, and renewal carries on, creating a dynamic yet serene rhythm deep within the heart of the forest. This quiet evolution is a reminder of nature's resilience, an ongoing process that continues, unfolding softly through time. Heavy rainfall seeps into the soil, saturating layers of earth and rock. As water accumulates, it increases the weight pressing down, creating a delicate balance within the ground. This added pressure can lead to gradual shifts as materials beneath the surface become more susceptible to movement. Over time, the combined forces of gravity and water cause some soil layers to lose their stability. Landslides may gradually unfold, displacing rocks and earth downslope terrain. The movement is often slow, a gentle flow of natural processes working in unison, reshaping the landscape. Trees and plants can also be affected, their roots no longer able to anchor securely in soil that has shifted beneath them. These changes can transform valleys, create new formations, or alter the course of streams. Surrounding ecosystems may adapt as the landscape evolves. The interplay of rainfall and geological structure continues, a silent but powerful force that gently reshapes the world over time. It is a reminder of the ever-changing nature of our environment, unfolding without haste. The Earth holds within it an immense mass of approximately 5.97 ect circumflex 24 kilograms. This substantial weight has remained fairly stable since the planet first formed, drawing together a blend of gases, dust, and rocky materials into a solid structure. Over billions of years, this mass has been shaped by natural forces, creating mountains, valleys, and oceans. While the overall mass stays largely unchanged, the planet experiences minor variations. Small amounts of meteoroids, tiny particles of space dust, and comets occasionally collide with Earth, gently adding to its total mass. These additions are subtle, like whispers from the cosmos, merging into the planet's existing layers without causing noticeable effects. The steady presence of this immense mass helps to maintain gravity, allowing everything on the surface to exist in harmony. As the Earth continues its slow journey through space, the deep, consistent weight remains a foundation for life and the natural processes that unfold over time. The Earth's mass, a defining characteristic, echoes the quiet, rhythmic patterns of our universe, always present, always steady. The carbon cycle flows gently through the Earth's systems, weaving together rocks, oceans, and the atmosphere in a serene, ongoing dance. Carbon atoms, ubiquitous and essential, journey through various forms and locations over millions of years. They can be found deeply embedded in solid rocks, where they remain stored for extended periods. These formations, created by ancient processes, hold carbon in a stillness that echoes the past. At the same time, oceans play a critical role in this cycle, absorbing vast amounts of carbon from the atmosphere. The water acts as a reservoir, holding dissolved carbon molecules that can slowly interact with marine life and sediments. This interplay creates a balance, with carbon being released and sequestered through natural processes, contributing to the stability of the planet's climate over geologic time. As these elements shift and transform, the carbon cycle serves as a quiet yet powerful force. It influences temperatures, weather patterns, and ecosystems, connecting distant times and places in a dynamic equilibrium. This cycle unfolds patiently, highlighting the intricate relationships within Earth's systems, each part contributing to the grand design of our planet. The steady movement of carbon whispers of a time that is both ancient and ever-present, allowing the Earth to breathe and change, yet remain anchored in its essence. Soil forms a vital foundation, quietly evolving through countless interactions over time to create a complex structure rich in nutrients. Each layer tells a story, with fine particles mingling with larger grains, creating a tapestry that supports life. This delicate balance of sand, silt, and clay, along with organic matter, provides the necessary framework for a variety of organisms to thrive. As microorganisms break down decaying matter, they release nutrients back into the soil, a process that flows seamlessly through the nutrient cycle. This cycle fosters fertility, replenishing essential minerals for plants. Roots gently tap into this reservoir, drawing up the sustenance needed for growth. In turn, plants become food for animals, completing this silent exchange of energy. Over time, soil becomes a stable haven, nurturing diverse ecosystems that depend on its richness. Decomposition enriches its texture and structure, enhancing its ability to retain moisture and provide support. This slow, almost serene process has given rise to a living blanket that supports various forms of life, ensuring the continuity of natural cycles. The rhythmic flow of nutrients and the quiet stability of soil exemplify a harmony that persists, fostering a serene interconnectedness among all living things. Within the quiet embrace of the forest floor, a remarkable network unfolds. Beneath the surface, threads of fungi weave through the soil, connecting the roots of various trees in a hidden relationship. This intricate system allows trees to share vital nutrients and communicate in subtle ways. Through these fungal connections, some trees can offer nourishment to nearby companions that may be struggling. When one tree faces a threat, such as an invasion by insects, it can send chemical signals through the fungi. Other trees, attuned to this quiet alert, respond by strengthening their own defenses. This exchange fosters a sense of community, where trees work together to ensure their mutual survival. This complex undercurrent of interactions supports the health of the entire woodland. Over time, this network becomes a living tapestry, linking the diverse species of the forest in a gentle dialogue. The rhythm of life unfolds softly as trees continue to thrive through this interconnectedness. Such phenomena illustrate the subtleties of existence, where cooperation and support thrive in silence, enriching the ecosystem. The whispers of life below ground carry on, encouraging a serene and enduring balance. Deep beneath the ocean's surface, hydrothermal vents create a surreal landscape of life. These vents arise from the heat of the Earth's interior, where molten rock warms surrounding water, releasing mineral-rich fluids into the dark depths of the sea. With temperatures often surpassing 700 degrees Fahrenheit, this scalding water carries essential nutrients that form the foundation of thriving ecosystems. Surprisingly, life flourishes in these extreme conditions, far removed from sunlight. At the vents, chemosynthetic bacteria convert the minerals from the water into energy. These microscopic organisms support a variety of creatures, such as giant tube worms, clams, and specialized crabs, all uniquely adapted to their environment. The reliance on chemical energy, rather than solar energy, allows these organisms to thrive in solitude, drawing sustenance from the chemical reactions occurring in the depths. Over time, these ecosystems persist in their seclusion, becoming vibrant oases in a world that usually depends on sunlight. Life here continues in a steady rhythm, anchored by the warmth and nutrients that flow from the Earth's core, revealing the remarkable resilience of organisms adapting to even the harshest of conditions. The quiet existence at hydrothermal vents invites contemplation of the wonders that persist in the unseen corners of our planet. Beneath our feet lies a dynamic world where Earth's plates move at an imperceptible pace, shaping the surface over countless ages. This movement, known as plate tectonics, unfolds gradually, often measured in mere centimeters each year. These tectonic plates float atop the semi-fluid asthenosphere, creating a canvas for the slow but relentless forces that drive them apart or push them together. As plates drift, continents gradually shift, altering landscapes and creating new features. Mountain ranges rise where plates collide, their jagged peaks formed by the immense pressure and heat generated from such interactions. In contrast, rift valleys can open where plates pull apart, making way for new geological formations. The ocean basins, too, shift and expand as tectonic activity reshapes the seafloor, resulting in the birth of more landforms. This long-term dance of the plates is woven into the very fabric of our planet, a silent orchestra of movement playing out over millions of years. Each creak and shift beneath the surface contributes to the Earth's evolving story, a reminder that change, though often imperceptible in a single lifetime, is a constant of the natural world, quietly crafting new terrains and shaping the essence of our planet. The journey of plate tectonics continues, seamlessly connected to the deeper rhythms of the Earth, ever unfolding and inviting our thoughts to drift along with it into the calm of sleep. Earth's surface temperature, an average of about 15 degrees Celsius, is a gentle reminder of the complexities within our environment. This average masks a wide range of temperatures, influenced by various factors such as geography, elevation, and the surrounding atmosphere. In some places, temperatures drop dramatically, as seen in the frigid expanses of Antarctica, where the cold can plunge to minus 88 degrees Celsius, a testament to the extreme conditions that can envelop a region. Conversely, in places like Death Valley, temperatures can soar to 56.7 degrees Celsius, showcasing the intense heat that can occur in more arid environments. This vast range unfolds gradually, influenced by long-term shifts in climate patterns and atmospheric changes. These variations in temperature arise from the interplay of sunlight, wind, and moisture, each element contributing to a delicate balance on the planet's surface. Over the years, temperature changes can reshape ecosystems, affecting how life thrives in different regions. These patterns of warmth and chill ebb and flow, reminding us of the Earth's ability to adapt and evolve in response to its own rhythms. Each fluctuation is a small part of a much larger story, an ongoing dance of warmth and cold that influences the landscapes we know. Beneath the canopy of stars, this gentle interplay continues, ever so softly moving forward into the quiet of the night. The water cycle is a serene and intricate process that guides water through its many states. From the moment water evaporates into the atmosphere, it begins a journey that can span thousands to millions of years. This transformation from liquid to vapor happens gradually, as warmth from the sun gently lifts water from oceans, rivers, and lakes, filling the air with unseen droplets. As these tiny particles rise and cool, they gather together, forming clouds that drift softly across the sky. Eventually, the weight of these droplets brings them back to the Earth as precipitation, nourishing the ground below and replenishing rivers and streams. This rainfall, a quiet gift of nature, soaks into the soil or flows across landscapes, making its way back to larger bodies of water. Sedimentation plays a vital role too, as the water travels over rocks and soil, slowly carrying particles with it. These sediments deposit themselves over time, shaping the Earth's surface and creating new features. Each stage of this cycle is a peaceful evolution, reflecting the passage of time and the interconnectedness of all water on the planet. With every drop falling gently, the water cycle continues its eternal rhythm, an ongoing process in perfect harmony with the natural world. The Earth's climate experiences slow, steady changes over time, influenced by a variety of natural factors. One significant contributor is volcanic activity. When a volcano erupts, it releases ash and gases into the atmosphere. These substances can momentarily cool the planet by blocking sunlight, creating a temporary shift in climate. However, over time, the effects of such eruptions fade, allowing the Earth to warm again. Another vital aspect of climatic changes involves variations in sunlight. The sun's energy reaches Earth with different intensity due to factors like its natural cycles and shifts in the Earth's orbit. These subtle changes cause fluctuations in temperature, gradually altering weather patterns across the globe. Such processes unfold over thousands of years, allowing for the delicate balance of ecosystems to adapt patiently. This gentle rhythm of change showcases the dynamic nature of the Earth. Each factor plays its part in a slow dance, shaping the environment in ways that are often imperceptible in the brief span of human existence. As temperatures adjust and climates evolve, the planet quietly adapts, reminding us of the profound connection within its natural systems. The Milankovitch cycles reveal a calm, rhythmic dance between Earth and the cosmos. These cycles describe the gradual changes in Earth's tilt, the shape of its orbit, and the slow wobble known as precession. Each of these elements plays a role in how sunlight reaches different parts of the planet over extended periods. The tilt of Earth shifts between more upright and slightly angled positions, affecting seasonal temperature variations. As the orbit changes shape from more circular to somewhat elliptical, the distance from the sun also fluctuates, subtly influencing climate. This slow transformation unfolds over tens of thousands of years, guiding the transition between glacial and interglacial periods. During glacial times, ice sheets blanket vast areas, while warmer periods allow for melting, leading to lush landscapes. These cycles weave together, gently orchestrating the Earth's climate and the distribution of ice. The intricate balance of these factors creates a natural ebb and flow, illustrating the deep connections within Earth's system. As these processes continue, they quietly shape the world around us, a testament to the slow yet powerful shifts of nature. The Earth's atmosphere, a delicate layer enveloping the planet, has maintained a steady consistency over millions of years. It is primarily composed of nitrogen, which constitutes about 78% of its volume, and oxygen, making up roughly 21%. This stable mixture is crucial for sustaining life as we know it. The gentle presence of these gases creates a balanced environment, allowing flora and fauna to thrive within various ecosystems. Throughout the ages, the atmosphere has evolved, yet its core components have remained remarkably consistent. The balance of nitrogen and oxygen supports respiration for countless organisms. Nitrogen, while not directly usable, plays an essential role in the cycles that nourish life on Earth. Oxygen, vital for many forms of life, is continuously replenished through natural processes such as photosynthesis. The atmosphere also serves as a protective barrier, shielding the planet from harmful solar radiation and maintaining surface temperatures suitable for life. This quiet stability allows ecosystems to flourish, responding gracefully to minor fluctuations in climate. Steady and unassuming, the atmosphere continues its role in nurturing the intricate web of life that exists on Earth, a reminder of nature's enduring embrace. The subtle dance of gravitational forces between the Earth, the Moon, and the Sun gives rise to the gentle ebb and flow of ocean tides. This natural rhythm, marked by rising and falling waters, plays a significant role in shaping the coastal landscapes. As the tides rise, they bring an influx of nutrients, while their retreat exposes the shoreline, creating a dynamic environment. Over time, the constant movement of tides continuously molds coastlines, creating varied shapes and contours. This ongoing process helps to shape beaches, estuaries, and rocky shores, illustrating the quiet power of water and gravity working in harmony. The shifting waters not only influence landforms, but also play a crucial role in marine ecosystems. As tides rise and fall, they create new habitats, delivering oxygen and nutrients to tide pools and intertidal zones. These areas become rich in life, hosting a variety of organisms that have adapted to thrive in this ever-changing environment. This continuous cycle of tidal movement nurtures delicate ecosystems, ensuring a balance in the marine habitats. The soft rhythms of the tides reflect nature's persistence and grace, a reminder of the connections that bind our planet together. The Earth's surface is a tapestry of shifting land masses, influenced by the slow but persistent movement of tectonic plates. These immense slabs of rock, nestled beneath our feet, are constantly in motion, drifting apart or moving towards one another very gradually over millions of years. This gentle movement reshapes the continents, altering their configurations and creating new geological features. As tectonic plates slide and shift, they can cause the land to rise or fall. Mountains may emerge where two plates collide, while valleys can develop in areas where the plates pull apart. The effects of these movements can be vast, influencing everything from the contours of coastlines to the formation of vast rift valleys. Each change, though sometimes imperceptible in a human lifetime, contributes to the slow evolution of the planet's surface. This ongoing process quietly reflects the Earth's dynamism, signifying a world that is never truly still. Each gradual shift in the land carries with it the weight of history, echoing through time as landscapes transform in silence. The surface of our planet is a reminder of the slow dance of geological forces, weaving a narrative that unfolds over expanses of time, gently cradling the land in a state of continuous change. The planet's magnetic field emerges from the movements within its liquid outer core, a swirling mass of iron and nickel. This field extends far into space, forming an invisible shield around the Earth. It gently guides charged particles emitted by the sun, known as solar wind, away from the surface, preventing them from reaching the atmosphere and impacting life. This protective barrier plays a crucial role in maintaining the delicate balance necessary for life to flourish. It creates a stable environment, allowing organisms to evolve and thrive in diverse conditions. Without the magnetic field, the Earth would be exposed to an unfettered barrage of cosmic radiation, which could disrupt the atmosphere and lead to harsher conditions for living beings. As the magnetic field interacts with solar particles, it creates beautiful displays of light, manifesting as the auroras near the polar regions, shimmering softly against the night sky. This dynamic interplay is a testament to the planet's complexity, showcasing the intricate relationships within its systems. The magnetic field thus cradles life, nurturing an atmosphere where countless forms can exist in harmony, a quiet guardian in the expansive universe. In Antarctica, there exists a remarkable site known as blood falls, a unique phenomenon where iron-rich water emerges from beneath glaciers. This water flows from the Taylor Glacier, escaping through a small opening and making its way down the ice, giving the overall scene a striking deep red hue. The iron within the water interacts with the air, creating a gentle oxidation process that results in its rusty appearance. The surroundings are stark and tranquil, adding to the otherworldly nature of this landscape. As the water seeps steadily from the glacier, it reveals a story of hidden life and ancient conditions locked within the ice. The high salt concentration in the water prevents it from freezing, allowing it to flow even in the extreme cold. Surprisingly, the salt also creates a brine that forms a unique ecosystem where microorganisms thrive in these subglacial lakes, drawing energy from the iron. This intricate balance reflects the hidden complexities of a seemingly harsh environment, enriching our understanding of life in extreme conditions. The slow trickle of the water continues, an unhurried presence in the frozen expanse. Caterpillars undergo a remarkable transformation as they prepare for the next stage of their life cycle. During this time, a behavior known as creeping takes place, where they begin to change both their body structure and coloration. This process is a fascinating display of adaptability, as they instinctively sense the approach of metamorphosis. In these moments, their bodies may shift subtly, with changes in posture as they find a secure place to rest. This transition often includes a deepening of colors or the appearance of patterns that were not visible before. The caterpillar's skin may grow taut as it prepares for the significant changes that lie ahead, indicating that it is ready to envelop itself in a protective casing. Within this casing, the caterpillar will undergo profound changes, reorganizing its body entirely. As it creeps along, a sense of anticipation fills the air, a quiet readiness for what is to come. This stage is crucial for the caterpillar, as it represents the calm before a vibrant emergence into a new form, illustrating the wonders of nature's cycles. The peaceful transformation continues, leading to a moment of stillness, holding potential in its embrace. Within the depths of the earth, the mantle plays a significant role in shaping the planet over vast periods. Here, convection occurs, a process where heat from the core rises and flows toward the surface. As this heat moves, it carries with it materials from the deep interior, creating currents that gently stir and displace the mantle's content. With time, these currents influence the movement of tectonic plates, which float atop the semi-fluid mantle like large sections of a slowly shifting puzzle. The interaction of these plates can give rise to remarkable geological structures. When plates converge, they press against each other, often resulting in the formation of mountain ranges, which rise majestically over millions of years. The gradual yet persistent nature of these movements shapes the landscape we know today, creating valleys, ridges, and a dynamic surface that is constantly changing, albeit at a pace too slow for the human eye to perceive. Each shift adds to the ongoing story of the Earth, a quiet and continuous transformation deep beneath the surface, awaiting the next breath of change. In the vastness of our planet's atmosphere, natural climate cycles quietly unfold, creating ripples in the weather that extend across the globe. Among these cycles are El Niño and La Niña, phenomena that arise approximately every few years, each bringing its own distinct influence on weather patterns. El Niño typically occurs when warmer water gathers in the central and eastern tropical Pacific Ocean, altering atmospheric conditions and inviting shifts in temperature and precipitation. This warm phase can lead to wetter conditions in some regions, while causing drought in others. Opposite this, La Niña emerges with cooler ocean temperatures in the same areas, reinstating a different set of atmospheric effects. Both cycles interact with one another, weaving periodically through a tapestry of changing weather that affects ecosystems, agriculture, and climates worldwide. These transitions can be subtle yet profound, reminding us of the dynamic nature of the Earth's systems, ever evolving yet connected in complex ways, creating an expansive rhythm that unfolds gently over time. Each cycle leaves its mark, adding to the intricate dance of our planet's climate fabric, existing in harmony with longer geological trends. Deep in the ocean, hydrothermal vents emerge from the crust of the Earth, creating a unique environment where heated water flows upward from the depths below. This water, rich with minerals and gases, bubbles to the surface, releasing energy and nutrients into the surrounding sea. The heat originates from volcanic activity beneath the Earth's surface, where the mantle's heat meets the cooler temperatures of the ocean. As water seeps through cracks in the ocean floor, it interacts with rocks and minerals, becoming rich with compounds that play a vital role in the vent ecosystem. This slow, steady movement of materials demonstrates a continuous connection between the Earth's interior and the vast ocean above. The heated water alters the surrounding environment, creating localized habitats that support unique organisms, thriving in conditions devoid of sunlight. These ecosystems, sustained by chemical processes rather than sunlight, showcase the remarkable ability of life to adapt and flourish in extreme environments. The flow of minerals and energy from the depths patiently shapes the ocean floor, a testament to the dynamic forces operating beneath the waves, blending the cycles of life and geology together in harmonious continuity. In a forest, life unfolds at a gentle pace, with changes occurring subtly over time. Natural disturbances, such as storms or wildfires, can reshape the landscape, allowing for new growth to emerge. As these events happen, the existing trees may die, creating gaps in the canopy. This allows sunlight to filter through, nurturing the growth of new plants and young trees that thrive in the newfound light. Climate shifts also play a significant role in these transformations. As temperatures rise or rainfall patterns change, some species may struggle to adapt, while others may flourish, leading to a gradual shift in the ecological balance. Over decades, a forest may evolve, showcasing different species that contribute to its structure and diversity. The slow cycle of life, death, and rebirth reveals a resilience rooted deeply within these ecosystems. Each change fosters new relationships between plants, animals, and the soil, forming a delicate web that sustains the forest over time. This ongoing process continues quietly, allowing life to flow softly through the trees, blossom in the underbrush, and move gently with the seasons. Beneath the surface of the earth, tectonic plates drift slowly, moving at a pace that is almost imperceptible. This gradual movement shapes the world around us, creating valleys that stretch wide and deep, and mountains that rise majestically against the sky. As these plates shift, they interact with one another, sometimes colliding gently or sliding past each other, a process that unfolds over millions of years. When plates collide, they can push up the Earth's crust, forming mountain ranges where once there was flat land. In other areas, as plates pull apart, they can create deep ocean basins that cradle the waters of the sea, allowing life to flourish in the depths. Each small shift in the plates contributes to the ongoing transformation of the planet's surface. This slow dance of the Earth beneath our feet illustrates a dynamic system, constantly evolving through time. It is a reminder of the grand scale of change that takes place far from our immediate sight, a continuous flow of geological activity shaping the world in ways we may not always observe. The cycles of formation and alteration blend seamlessly into the Earth's timeless rhythm, echoing softly through the ages. The warmth of the sun reaches the Earth, casting its influence over the atmosphere, where it stirs the air and generates weather patterns that change from day to day. This radiant energy also warms the oceans, allowing currents to flow across vast distances, shaping the climate in subtle yet profound ways. The interplay of heat, water, and air creates a dynamic system where gentle breezes and heavy storms alike are born from the same source. Over time, as temperatures rise or fall, these patterns can shift. Changes in climate gradually alter habitats as plants and animals respond to new conditions. Regions that once flourished may become drier, while others can transform into lush environments, fostering an array of life. Species, in their quest for sustenance and survival, begin to migrate, seeking balance in their changing world. This slow evolution is a testament to the resilience of life on Earth, as everything adapts in rhythm with the ongoing dance of warmth from the sun. As these natural processes unfold, they form a delicate balance, reflecting the interconnectedness of all living things. The Earth continues to breathe and shift, ever guided by the gentle cycle of heat and time, moving steadily through its own story. Earth's composition, a rich tapestry of elements and compounds, leads to an average density of approximately 5.52 grams per cubic centimeter. This measurement signifies not only the size of the planet, but also the intricate layers that lie beneath the surface. The core is predominantly composed of iron and nickel, contributing significantly to this density, while layers of rock and minerals above it add complexity to the overall structure. Over geological timescales, this average density remains fairly stable, a testament to the balanced processes that shape the Earth. However, in localized areas, variations can occur. Dense igneous rocks may create pockets of higher density, while regions with lighter sedimentary formations can have slightly lower measures. These natural nuances result from the intricate dance of geological processes, including volcanism, erosion, and sediment deposition. Such variations reflect the dynamic nature of Earth's crust, always in a state of gentle transformation. Continents shift and reshape, slowly altering the density distributions across the planet. Through it all, the average density stands as a quiet constant, cradled within layers of time and change, inviting curiosity about the secrets held beneath our feet. In the Arctic, where icy waters maintain a chill that lingers far below freezing, certain fish have evolved remarkable adaptations. These species possess antifreeze proteins within their blood, a fascinating biological feature that allows them to thrive in an otherwise harsh environment. These proteins work by lowering the freezing point of the fish's bodily fluids, creating a protective barrier against the icy conditions surrounding them. As temperatures drop to extremes, these proteins effectively prevent ice crystals from forming within their cells. This adaptation is a delicate dance of chemistry, ensuring that the fish can maintain fluid circulation and continue to carry out their essential biological processes. Without this incredible mechanism, survival in such frigid waters would be nearly impossible. The presence of antifreeze proteins in these Arctic fish is a subtle reminder of the intricate ways life persists in even the most extreme habitats. It is a gentle testament to the resilience found in nature, where life adapts to flourish against all odds. Observing these wonders, one can appreciate the beauty of adaptation, a quiet marvel mingling with the glacial waters of the north, harmonizing with the rhythm of survival. Near waterfalls, a gentle hum fills the air, blending soothingly with the rush of water. This sound is part of a phenomenon known as Brownian motion, where tiny particles dance in random directions, influenced by thermal energy. As these minute particles move, they collide and interact, creating pleasing auditory experiences that can surround you in serene natural spaces. The water droplets swirling through the air near the falls, along with the small particles present in the atmosphere, engage in this chaotic yet harmonious motion. Each tiny movement contributes softly to a continuous soundscape, echoing the rhythm of nature itself. The gentle hum can also be observed in various insects, where similar interactions create their own unique symphony of sounds. This peaceful noise, often unnoticeable at first, invites a sense of calm. It serves as a reminder of the complex interplay of elements that surrounds us, a tranquil backdrop to the ordinary moments of life. Every slight movement, driven by thermal energy, adds to the layered experience of the natural world, creating a soft, rhythmic melody that carries quietly through the air, inviting relaxation and reflection. Deep within the earth, at its very center, lies the inner core. This core is a solid sphere primarily composed of iron. Beneath the layers of rock and molten material, it exists in a world where conditions are extreme. The temperature here is incredibly high, comparable to the surface of the sun, yet the immense pressure from the layers above keeps the iron in its solid state. Despite the heat that would ordinarily cause iron to melt, the crushing weight of the Earth's crust and mantle prevents such a transformation. Instead, this solid inner core remains stable and steadfast. It holds a unique place within the planet, donning a structure that contrasts with the fluid outer core surrounding it. The solid nature of the inner core provides an anchor point, balancing the dynamics of the surrounding liquid layers. This internal strength continues to influence the behaviors of the materials around it, enabling a lasting interaction that shapes the nature of our planet. The inner core, quietly solid and enduring, continues its role far beneath our feet, adding to the complexity of Earth's structure, remaining a hidden world of stability amid shifting elements, patiently waiting for the next exploration into its mysteries. In a remote part of the world, at Vostok Station in Antarctica, the coldest natural temperature was recorded, resting at an astonishing -128.6 degrees Fahrenheit, or -89.2 degrees Celsius. This extreme cold was measured in 1983, capturing a moment of profound chill. Vostok Station is situated near the ice-covered surface of a vast subglacial lake, which lies beneath thick layers of ice. The conditions here are unlike anywhere else on the planet, where the atmosphere is thin and winter nights can be long and unyielding. As temperatures drop, the air becomes still, and the surrounding ice remains solid and unchanging. This remarkable record showcases the extremes of Earth's environment, where such low temperatures can be reached under specific conditions. The perpetual ice enveloping the station offers a glimpse into a world shaped by cold, untouched by the more temperate climates found elsewhere. Such frigid conditions create a unique interplay of physical processes in the atmosphere and ice, revealing the quiet yet intricate nature of our planet's climate. This delicate balance continues deep within the icy expanse, inviting a sense of calm introspection and wonder at the natural world. In the heart of arid landscapes, there occurs a beautiful transformation known as desert greening. Here, in the vast expanses of dry earth, patches of vegetation can spring to life, following a rare and heavy rainfall. This sudden burst of growth can sometimes cover large areas with vibrant flowers, painting the ground with colors that seem to defy the surrounding desolation. These blooms represent a remarkable survival strategy for plants adapted to extreme conditions. They have evolved to seize any chance for reproduction, responding quickly to the brief availability of water. The rain, often a fleeting event, prompts seeds lying dormant beneath the surface to awaken and push through to the light. During this time, the desert floor transforms, creating a striking contrast between the lush greenery and the parched terrain. It is a moment of abundance, though temporary, as the flora makes the most of the moment before returning to stasis in the dry air. This cycle offers a glimpse into the resilience of life, showcasing a quiet interplay of conditions that can create vibrant life in the unlikeliest of places. The quiet aftermath of such events leaves behind a sense of anticipation, ready to embrace whatever comes next in this ever-evolving landscape. The Earth's crust, a delicate yet robust shell surrounding our planet, varies in thickness from about 5 to 70 kilometers. Beneath the vast oceans, the crust is generally thinner, while under the continents, it can extend deeper, creating a diverse landscape of rock and mineral formations. This layer, though seemingly stable, is subject to slow but ongoing changes. Tectonic activity gently reshapes the crust over time, driven by the movements of underlying layers in the mantle. These movements can cause the crust to thicken in areas where plates collide or sink into the earth in zones of subduction. Similarly, in regions where plates pull apart, new crust may form from molten rock that rises to the surface, resulting in volcanic activity and the creation of new land. Over millions of years, these processes contribute to the ever-changing face of our planet. The steady rhythms of tectonic activity may not be visible in a single moment, yet they guide the complex dance of geological evolution, shaping valleys, mountains, and various landforms. The crust remains a part of a larger system, quietly adapting and transforming, holding the stories of the earth within its layers. Life continues on, with the ground beneath providing a stable foundation as these changes unfold over time, creating an atmosphere of calm anticipation for what is to come. Mountains, majestic and enduring, take shape over millions of years through the gentle embrace of tectonic plates colliding deep beneath the surface of the earth. This slow yet powerful movement allows layers of rock to be lifted and compressed, forming peaks that rise intricately from the ground. As these layers ascend, they intertwine with others, creating rugged ridges and valleys that define the landscape. The process continues over vast stretches of time, with the Earth's crust slowly bending and folding, generating a tapestry of geological features. The collision of these plates can create dramatic shifts, pushing up some regions higher while leaving others in serene valleys. These actions not only mold the mountains themselves, but also influence the flow of rivers and the shape of the surrounding terrain, quietly guiding nature's design. As rocks weather with time, the mountain faces slowly soften, and the relentless forces of wind and water carve paths, bringing further change while preserving the essence of what these grand formations represent. This constant, gentle transformation of the landscape reflects the ongoing dance of elements beneath the surface, where time flows seamlessly, nurturing the beauty of Earth's varied terrain. In this peaceful cycle, mountains stand timeless, a testament to nature's slow, persistent artistry. At great heights, the conditions change, and air becomes thinner with each upward step. Above approximately 8,000 meters, which is often referred to as the death zone, the atmosphere holds less oxygen. As humans ascend into this rarefied air, the body struggles to acclimatize to the diminished supply. Breathing becomes more labored, and the vital life force that oxygen provides grows increasingly scarce. In this elevated realm, the body's natural responses kick in, attempting to compensate for the lack of air. Heart rates may quicken, and there might be an urgent need for additional breaths. Yet these efforts may not be enough to sustain life for long. The effects of altitude can overwhelm the senses, often leading to confusion and fatigue. The landscape shifts dramatically at these heights, showcasing stark beauty, but alongside it comes a quiet reminder of the limits of endurance. Each breath taken is a precious exchange, a dance with the thin atmosphere, reminding us of the world's vastness and the fragility of existence at such elevations. The mountains stand tall, their peaks touching the sky, while creation whispers of the delicate balance between life and the unyielding elements. As nature continues to breathe and shift, the rhythms of the earth hum softly, inviting contemplation of the wonders held in its embrace. The warmth of sunlight gently bathes the earth, its energy penetrating the surface and warming the ground, the oceans, and the vast expanses of the atmosphere. This absorbed energy creates a delicate balance, setting into motion currents of air that flow and swirl like an unseen dance. These convection currents, formed by the rising of heated air, transport warm air upward and allow cooler, denser air to settle in its place. As this process unfolds, moisture within the atmosphere begins to gather. Tiny water droplets condense and swirl together, coalescing to form clouds that float serenely across the sky. Over time, these clouds grow and shift, influenced by the gentle currents swirling beneath them. The interplay of temperature and pressure creates the conditions necessary for precipitation to occur, as raindrops break free from the clouds and tumble down to the earth. This continuous cycle not only replenishes the rivers and lakes, but also nourishes the life that depends on it, subtly shaping the landscapes over countless seasons. The atmosphere, ever dynamic, remains a tapestry woven from the harmony of sun, air, and water, reminding us of the intricate systems that support existence. As these natural processes carry on, the world breathes in quiet rhythms, each element contributing to the larger picture of our home. Large ice sheets blanketing the polar regions have existed for millions of years, their icy surfaces reflecting sunlight and helping to regulate the temperature of the earth. Occupying vast areas, these colossal formations are composed of layers of compacted snow, each layer telling a story of past climates and atmospheric conditions. As the ice accumulates, it grows thicker, pressing down under its own weight, forming deep glaciers that flow slowly toward the ocean. The presence of these ice sheets plays a crucial role in shaping global climate patterns. They act as a natural air conditioner, cooling the surrounding atmosphere and influencing weather systems far beyond their frozen borders. When temperatures shift, the ice responds, either expanding or receding, subtly impacting sea levels as water is stored or released into the oceans. This continuous interaction between the ice sheets and the environment drives intricate processes. Changes in the volume of ice can alter ocean currents, which in turn affects heat distribution across the globe, creating ripples that influence everything from ecology to weather patterns. As glaciers melt and reform, they also release fresh water into the sea, nourishing marine ecosystems and shaping coastlines gently over time. Each movement, each transformation, is a reminder of the dynamic balance that sustains our planet, a balance quietly unfolding in the stillness of the polar regions. The tectonic plates that compose Earth's crust glide over the semi-fluid layer beneath them, moving at a measured pace of approximately 1 to 15 centimeters each year. This gradual movement highlights the enduring yet subtle nature of geological change. Each plate is a massive expanse of solid rock, shaped over millions of years by the forces of nature. They interact with one another along their boundaries, where their slow dance can create a variety of phenomena. As these plates shift, they may collide, pull apart, or slide past each other. When they converge, they can form mountains or trigger earthquakes. When they drift apart, new oceanic crust emerges, gently reshaping the seafloor. This slow churn of the earth contributes to the ongoing evolution of landscapes, from serene valleys to rugged peaks, all shaped by the persistent movements beneath the surface. The rhythm of tectonic activity is a reminder of the planet's complex yet steady process of transformation. Each shift is not abrupt, but rather a quiet adjustment in the grand story of Earth's development, unfolding continuously over vast stretches of time. The Earth breathes in this way, its surfaces adapting imperceptibly as the plates glide onward, maintaining a calm, enduring presence. Earth's crust, a thin yet intricate shell, consists of a mosaic of tectonic plates. These plates move, albeit slowly, at a rate of just a few centimeters each year. This seemingly modest pace has profound effects over time, contributing to the gradual transformation of the landscape. As they shift, they pull apart, collide, or glide against each other, creating a dynamic environment beneath the surface. The movement of these plates affects the landforms we see, shaping mountains, valleys, and ocean basins. Each gentle movement may lead to small elevations or subtle depressions, slowly altering the contours of the land. Occasionally, the tension that builds at the edges of these plates results in seismic activity, releasing energy that gives rise to earthquakes. In this way, the slow and steady dance of the plates plays a crucial role in the Earth's ongoing geological story. The process unfolds seamlessly, a continual reminder of the Earth's living nature. Over millions of years, each small shift weaves together to create a vast tapestry of geological history, where every inch of movement contributes to the ever-changing face of the planet, calmly evolving beneath our feet. The atmosphere envelops our planet, stretching approximately 10,000 kilometers above the surface, forming a protective veil. This vast expanse consists of multiple layers, each with its own distinct characteristics. However, most of the weather we experience takes place within the first 12 kilometers of the troposphere. Here, the delicate interplay of temperature, moisture, and air pressure shapes the conditions we feel every day. In this lower layer of the atmosphere, air is warmer and more humid than in the layers above, allowing clouds to form and storms to develop. The gentle rise and fall of air currents create a rhythm of calm and chaos. As warm air rises, it meets cooler air, forming the building blocks of weather systems, from soft rain to billowing storm clouds. The troposphere is alive with activity, creating a dynamic environment conducive to change. Each oscillation and shift within this layer contributes to the ever-evolving patterns of our atmosphere. Weather systems move fluidly, altering the climate in ways both subtle and dramatic. This constant cycle of motion and stillness coexists harmoniously, a natural dance that continues day and night, reflecting the tranquility of Earth and its surrounding air. Challenger Deep lies quietly at the bottom of the Mariana Trench, the lowest point on Earth's surface. This profound depth reaches approximately 10,984 meters below sea level, a realm where darkness prevails and pressure builds steadily. The immense weight of the water above creates an environment that is both alien and serene. As one descends into this underwater abyss, temperatures drop significantly, often hovering just above freezing. Despite the inhospitable conditions, remarkable life forms can still be found here, adapted to survive where sunlight cannot reach. Organisms thrive in total darkness, drawing energy from the chemicals that seep from the ocean floor, transforming the deep sea into a unique ecosystem. The Challenger Deep serves as a reminder of the planet's extremes, illustrating how life can flourish in even the most challenging environments. The stillness of this submerged world, coupled with the continuous ebb and flow of ocean currents above, reflects a deep tranquility, inviting thoughts of exploration and discovery. The depths below remain a captivating mystery, whispering secrets that await gentle unraveling. Volcanoes breathe life into the earth, reshaping the landscape with each eruption. When lava flows from a volcano, it moves gracefully, solidifying into solid rock as it cools. This powerful process gradually transforms the terrain, creating new features and altering existing ones. Over time, layers of hardened lava accumulate, building up tall mountains or forming new islands amidst the ocean. The cycles of eruption and dormancy govern this slow evolution, marking the land with traces of molten rock and ash. Each eruption contributes to a tapestry of geological change, where the ground continuously adapts and renews itself. Even centuries after an eruption, the scars of the past remain, offering clues to the dynamic history of the region. From towering peaks to islands that rise from the depths, the work of volcanoes reminds us of the ever-changing nature of our planet. Peacefully, the earth reshapes itself, inviting curiosity and wonder at the beauty of transformation found within the quietude of time. The land rests, waiting for the next gentle shift in its ongoing story. The earth, a dynamic sphere, is composed of three principal layers, each with its own characteristics. The outermost layer, known as the crust, is a thin veneer of solid rock. This crust is fragmented into tectonic plates, which float gently on the layer beneath. Below this delicate shell lies the mantle, a much thicker region made up of solid rock that flows at an imperceptibly slow pace. This flow allows for the gradual movement of the crust above, a silent dance occurring over countless years. The mantle's composition includes silicate minerals, which provide a rich texture and varied properties that help drive the convective currents within. These slow-moving currents play a crucial role in the recycling of materials deep within the earth. As the mantle shifts and stirs, it interacts with the crust above, leading to changes in the landscape over geological timescales. Beneath the mantle lies the core, but it is the gentle interplay between the crust and mantle that embodies Earth's ongoing evolution. Each layer contributes to a symphony of geological processes, coaxing the landscape to shift and transform over eons, quietly reshaping the planet's surface. In this vast stillness, the Earth continues its unhurried journey, ever cycling through its timeless rhythms. The slow rotation of the Earth creates a gentle rhythm that affects both ocean currents and atmospheric circulation patterns. As the planet spins, it causes warm air and water to shift, creating currents that move across vast distances. This movement influences temperatures and weather conditions in different regions. Ocean currents, for instance, transport warmth from the equator towards the poles, while colder waters flow from polar areas back towards the tropics. These currents weave a tapestry of temperature variations that contributes to the climate of coastal areas, fostering ecosystems rich with life. Simultaneously, Atmospheric circulation follows a similar pattern, responding to the uneven heating of the Earth's surface. Warm air rises, creating low-pressure areas that invite cool air to flow in, resulting in gentle breezes and shifting weather systems. In time, these interactions foster gradual changes in climate, showcasing a delicate balance that shapes the environment. Such processes continue in a peaceful loop, quietly influencing the world from the depths of the oceans to the heights of the skies, ebbing and flowing with the passage of time. Gravitational acceleration at the surface of the Earth is a consistent force, measured at approximately 9.81 meters per second squared. This gentle pull keeps everything anchored toward the ground, creating a comforting sense of stability in our surroundings. While this value remains mostly unchanged over time, it can experience subtle variations depending on altitude and local geological features. At higher altitudes, gravity feels slightly weaker, as an increase in distance from the Earth's center reduces the gravitational pull. In contrast, areas with denser geological structures may exert a stronger pull, a phenomenon that reflects the complex and dynamic nature of our planet's interior. These slight differences illustrate the intricacies of the Earth's composition and how it lends to an ever-present, yet gentle force that shapes our existence. The consistent embrace of gravity contributes to a sense of balance within the natural world, quietly guiding movements and interactions. As this gravitational force remains stable, it nurtures an environment of calm predictability, allowing various physical systems to interact in harmony, fostering a peaceful rhythm across the landscapes of our world. The world around finds its rhythm in the quiet embrace of night. Each gentle breath, a whisper of calm, invites stillness. Softness blankets the landscape where shadows play, cradling every blade of grass and leaf. The air is cool and soothing, brushing softly against the skin as if nature itself is tucking you in, inviting moments of rest. Soft sounds, perhaps a distant rustle or the gentle sigh of the wind, mingle with your thoughts, wrapping them in a tranquil hush. Time seems to stretch and fold, creating a cocoon of comfort that allows eyes to grow heavy. A sense of release washes over, where worries fade into the soft darkness, and all that remains is a gentle pulse of calm. This serene stillness, like the gentle rise and fall of a slow, deep breath, lulls the mind toward a peaceful sanctuary. Every heartbeat is a reminder of this moment, where quietude reigns. Such an inviting space opens up as you sink deeper, allowing thoughts to drift away like clouds, soft and light. In this cherished silence, the world slows, whispering a gentle farewell, filled with warmth and peace. Good night from Sleepy Science Facts.